Hello, grade 10 learners. Today we are going to learn about patterns and sequences. At the end of this lesson, the student should be able to define sequence, finite sequence, and infinite sequence, list the next few terms given several consecutive terms of a sequence, identify few terms in a sequence given its general term, and derive a mathematical expression or rule for generating the sequence by pattern searching. Now let's start. Let us first begin with this activity. Our task is to find the next three terms and write the pattern. So for number 1, we have B, C, D, F. What have you observed about the pattern? That's correct. These are examples of consonants letters. So it means that the next three terms are G, H, J. For number 2, we have 5, 9, 13, 17. What have you observed about the pattern? Very good. The pattern is to add 4 to each succeeding numbers. So it means that the next three terms are 21, 25, 29. For number 3, we have 1, 3, 6, 10. What have you observed about the pattern? That's correct. So from the first term, we simply add plus 2, plus 3, plus 4, plus 5, and so on. So it means that the next three terms are 15, 21, 28. So for number 4, we have 20, 10, 0, negative 10. What have you observed about the pattern? Very good. So the pattern is to minus 10 to each succeeding term. So we have negative 20, negative 30, negative 40. And lastly, for number 5, we have 2, 4, 8, 16. What have you observed about the pattern? Very good. The pattern is to multiply 2 to each succeeding numbers. So the next three terms are 32, 64, and 128. Very well done, guys. So the patterns that we just obtained from our activity are examples of sequence. A sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. So each number in a sequence is called a term. For example, we have 7, 10, 13, 16, 19. So for the first term, which is 7, it is denoted by a sub 1. For the second term, denoted by a sub 2, that is equal to 10. For the third term, we have a sub 3, that is equal to 13. For the fourth term, that is denoted by a sub 4, which is equal to 16. The fifth term is a sub 5, and that is equal to 19. And so on. So let us try to identify the two types of sequence. So the first one is, for example, we have 7, 10, 13, 16, 19, and so on. The ellipsis dots indicates that the sequence goes on infinitely. So this one is called infinite sequence. A sequence is infinite if its domain is the set of positive integers without a last term. But if we are going to stop at a certain term, for example, we have 7, 10, 13, 16, 19, and we stop at 19. So this one is called a finite sequence. A sequence is finite if its domain is the set of positive integers which has a last term. So from our example, what do you think is the rule for generating this type of sequence? So the general or nth term is denoted by a sub n equals 3n plus 4. So let us check if the given general term will yield the correct sequence by substituting consecutive positive integers to n. So for the first one, a sub 1, we simply substitute n by 1. So we have 3 times 1 plus 4. So the answer is 7. For the second term, or the a sub 2, we have 3 times 2 plus 4, which is 6 plus 4. That's why we have 10. For the third term, we have a sub 3, which is 3 times 3 plus 4, and that is 9 plus 4. So the answer is 13. For the fourth term, which is a sub 4, equals 3 times 4 plus 4. So we have 12 plus 4, which is 16. And for the fifth term, we have a sub 5 equals 3 times 5 plus 4 is 15 plus 4. That's why we have 19. So it means that the general term that we obtain yields the correct sequence. So when given the general term of a sequence, you can find the other terms easily. So for example, find the first four terms of the sequence whose general term is given by a sub n equals the quantity of n minus 3 raised to n. So for the solution, we simply substitute n by positive integers. So the first one is a sub 1 equals the quantity of 1 minus 3 raised to 1. So that is negative 2 raised to 1, and that is negative 2. For the second term, or a sub 2, we have quantity of 2 minus 3 raised to the second power, and that is negative 1 squared. Negative 1 squared, we simplify, that will give us 1. For the third term, which is a sub 3, equals the quantity of 3 minus 3 raised to 3, and that is 0 raised to 3, so we have 0. And for the fourth term, we have the quantity of 4 minus 3 raised to 4, and that will give us 1 raised to 4, and that is equal to 1. So therefore, the first four terms of the sequence whose general term is given by a sub n equals the quantity of n minus 3 raised to n is negative 2, 1, 0, 1. Let's have the second example. Find the first four terms of the sequence whose general term is given by a sub n equals 1 over n plus 2. So here, again, we need to substitute the n by positive integers. So we begin by a sub 1. A sub 1 is equal to 1 over 1 plus 2, and that is 1/3. For the second term, we have a sub 2 equals 1 over 2 plus 2, and that is equal to 1/4. For a sub 3, we have 1 over 3 plus 2, and that will give us 1/5. For the fourth term, which is a sub 4, equals 1 over 4 plus 2, and that will give us 1 over 6. So the first four terms of the sequence whose general term is given by a sub n equals 1 over n plus 2 are 1/3, 1/4, 1/5, and 1 over 6. So for our next activity, we need to write down the n term or the general rule of each sequence suggested by the pattern. Let's begin with number 1. We have 3, 6, 9, 12, 15. So these are multiples of 3. So it means that the n term is a sub n equals 3n, or 3 times n. For number 2, we have 1, 8, 27, 64, 125. Notice that these are cubes of numbers. So the general term is a sub n equals n raised to 3. What about number 3? We have 1, 1/2, 1/3, 1/4, 1/5. So notice that the denominators increase consecutively. So the general term is a sub n equals 1 over n. For number 4, we have negative 3, 6, negative 9, 12, negative 15. So notice that these are multiples of 3 whose signs alternate. So it means that we need to get negative 1 raised to n, and then we multiply it by 3n. So the general rule is a sub n equals the quantity of negative 1 raised to n times 3n. And for number 5, we have 1, 4, 9, 16, 36. What do you think is the nth term of this sequence? So that's correct. These are perfect square numbers. That is why the general rule or the nth term is a sub n equals n squared. Now try doing this on your own. Until our next session, thank you and enjoy learning.